students, I am Shalika from Department of Computer Applications. Today I am going to discuss a topic of non-deterministic pushdown automata. In this topic I will discuss definition, moves and language accepted by the non-deterministic pushdown automata. Dear students, I already discussed the concept of pushdown automata in my previous video, and I already explained that the pushdown automata is of two types. First one is the deterministic pushdown automata and second one is the non-deterministic pushdown automata. And non-deterministic pushdown automata is very much powerful as compared to the deterministic pushdown automata because there are so many languages, there are so many CFGs that can be accepted by the non-deterministic pushdown automata, but they are not accepted by the deterministic pushdown automata. So, non-deterministic pushdown automata is powerful than the deterministic pushdown automata. And then next example, I will explain this thing in detail. I already discussed at the in previous video that pushdown automata is a collection of 7 tuples, in which I already explained that the 7 tuples are in which the Q is the finite set of states, sigma is the set of inputs, this one is the toss symbol and it is the collection of stack symbols, Q0 is the initial state, Z is the stack symbol, F is the final state and delta is the transition function. All functions are same as I discussed in the deterministic pushdown automata video. Just there is a difference in mapping function. That means there is a difference in transition function. That in NFA, if we are passing a input to a state, then it may be possible that we can reach to the number of states. Suppose we pass we are on state Q0 and input is A and the stack symbol is 0. It may be possible that at the same time we are moving to the Q1 state and at the same time it may be possible that we are remain on the same state. So in non-deterministic pushdown automata we can move to the multiple states at a time. Now the example of non-deterministic pushdown automata, let we have a language L is equal to let L is a language which contains WWR, where W is a string and it contains the symbols like A and B and the combination of A and B. So here W is a string. As we already studied one numerical related to deterministic pushdown automata, I already discussed this example with you in my previous video. For this example, we push all the elements of W and pop all the elements corresponding to WR. First of all, we just push the elements of W, and when C occurs, it indicates the center basically. It indicates center. So we didn't perform any operation related to C. We just push, suppose in that example we taken in, suppose we have a string W is equal to AB and the reverse of W is BA. So we push the elements of all the elements of W into the stack, and when the elements of WR occurs, then we pop all the elements. I'm just giving a brief introduction of this video. For A, we just push A. After it, for B, we push B. Now there is a C. For center, we didn't perform any operation. When B occurs, then we just pop, and the top of the stack is also B. That means we have a same inputs, same symbols on same input symbol and stack symbol is same. So we just perform the pop operation, and when the input symbol is A, top of the stack is also A, then we perform the pop operation. That means that's all the basic concept of deterministic pushdown automata. Now, but in this example, in this language, we have a language WWR. That means we didn't have any center here. Suppose let's take an example. Again, I'm going to take this string W is equal to AB, WR is equal to BA. Now here we didn't know that when we have to push all the elements and when we have to pop the elements, because we didn't know any center elements. If I perform the strategy of this example, then according to this example, when the stack is empty, it first of all, whenever the stack is empty, first of all we have to put the initial symbol of the stack. So we just push the initial symbol of the stack. So we push Z0. After that, for A we push A. Then B comes, that means input symbol is B, top of the stack is A. Symbols are totally different, so we just push this element also. I am using the same technique that I use in this example. In this example, I just use I push all the elements of W onto the stack, and whenever the different elements occur, that means, whenever the same elements occur, that means input symbol is B and top of the stack is also B. Then I just pop the element. When input symbol is A, top of the stack is also A, so I perform the pop operation. I am using the same concept here. That means if input symbol and top of the stack is same, then I am going to use the pop operation. So I am just using that concept here. For A, I used to, first of all, this one is the first input symbol, so I have to push it. Now for B, top of the stack is A, so I push it. Now B occurs, that means input symbol is B, top of the stack is also B. Input symbol is B, top of the stack is also B, that means they are same, so I have to use the pop operation. So this B is popped. Now again, input symbol is A, top of the stack is also A. So both symbols are same, so I used to perform the pop operation. Now it comes across the Z0, that means top of the stack contains Z0, it indicates that my string is accepted. But what happens if my input string is this, AA, my string is this AA, and then WR is again also AA. Now, it means WWR means A. Now, just perform the same technique on this example. Same technique. First of all, start symbol is Z0. Now, first input symbol A, I just push it. Now, input symbol is A, top of the stack is also A. I am using the same technique. If input symbol A and top of the stack symbol is same, then I have to perform the pop operation. Now, input symbol is A, top of the stack is also A. Then I have to pop this A, but this one is not a center. So this one is not a center. So that means the way that I am doing the concept is wrong. So I am just popping the elements before the center point. So for this example, for this problem, I have to use two steps. That means first of all, I have to take care of that whenever the input symbol is A, whenever the input symbol and top of the stack symbol is same, I have to perform the pop operation. And whenever the input symbol and top of the stack symbol is same, then I have to use the push operation. That means, again I am going to repeat this point. Input symbol is B, top of the stack is B. Both symbols are same, so I have to use the pop operation. But in this case, input symbol is A, top of the stack is A. Both symbols are same, but I have to use the push operation. Because if I pop it, if I pop this symbol, I am just popping this symbol before the occurrence of the center point. So for same input symbol, that means suppose I am on a Q0 state and input symbol is A, top of the stack is Z0. First of all, I am using the push operation, and also I am going to use the pop operation. I am using more than two operations on the same state. Pop operation is also there. Fine. So for the same input symbol, for A, I am going to use more than two states. That means I am doing the push operation also, and I am going to perform the pop operation also. So this problem is non-deterministic state, because for same input symbol, if I am on a state Q0 and input symbol is A, I am performing two operations simultaneously, and I'm going to the next state, and I'm going to the different next states. That means I'm going to Q1 state, Q0 state, as well as on Q1 state. I'm performing the push operation as well as I'm going to perform the pop operation. Now, just let's write the transitions rules of this diagram, of this language. That means, first of all, if I am on state Q0, input symbol is A, top of the stack is Z0, then I have to perform the push operation. That means Q0, A, Z0. It may be possible it may not be, it is always not necessary that my string starts with A input symbol. It may be possible that my string starts with the B input symbol. So if B input symbol is there and top of the stack is Z0, I am just pushing this symbol onto the stack. Now, next one, if I am on state Q0 and input symbol is A but top of the stack is B. That means input symbol is A, top of the stack is B. Both symbols are different, so I am just performing the push operation. Now again, if input symbol is B and top of the stack is A, symbols are different. Input symbol is different, top of the stack is different, so I am going to perform the push operation. Fine. Now, if I am in state Q0 and input symbol is A, top of the stack is again A. Now, for same input symbol, I have to perform the two things. As I already discussed, that first of all, I have to use the push operation, and second one, I have to perform the pop operation. So, first of all, I am going to perform the push operation for same input symbols. And it may be possible that input symbol is A, top of the stack is A, input symbol is B, top of the stack is B. So I'm just going to perform the push operation. Fine. Now, first of all, I have to perform the push operation. These all are the operations that are using the push operation. And it may be possible that we are on state Q0, input symbol is A, top of the stack is A. As I already discussed, I have to perform the pop operation. Right. So, for same input symbols, as I didn't know the center point of this language, so for both the inputs, if both symbols are same, that means input symbol and top of the stack symbol is the same, I have to perform more than one operation. That means for same input symbols A, I am going to perform a push operation. For same input symbols, that means input symbol is B, top of the stack is B, I am going to perform the push operation. But in this case, if input symbol is A, top of the stack is A, that means both symbols are same, I am going to perform the pop operation. And it may be possible that the string starts with B. If the input symbol is B, top of the stack is B, then again I am going to perform the pop operation. It's fine. So here I think now you are able to understand that this one is a non-deterministic pushdown automata, because for same input symbols, for same symbols, I am going to perform more than one operation. Here I am performing the push operation, here I am performing the pop operation, and I am going to more than one state. And more than one state, that means this one is only possible in case of non-deterministic pushdown automata. In deterministic pushdown automata, if I am on current state, then I will go to maximum one state. I will go to maximum new one state. Next state is only one. Fine. Whereas in case of non-deterministic pushdown automata, we can move to the more than one stage. We can perform more than one operation on a same stage, and it may be possible that the state will move to the more than one stage. Now, at last, when I perform all the operation, I am considering all the cases. I am considering if the input symbol is different, if the input symbol is same, then I have to perform the push operation as well as I have to perform the pop operation. At last, when our input string is finished, that means now I am performing all the push and pop operation. That means now no input string is there, no input alphabet is there, and top of the stack is Z0, and then I am going to the final state, and top of the stack is this. Fine. That means now no input symbols are finished. Now I didn't have any input symbol, so input symbol is epsilon, and top of the stack is Z0, and then I just move to the final state, and top of the stack remain contains the Z0. So this one is the language acceptance. So this one is known as the language acceptance through final state. Final state. As I already discussed that in case of pushdown automata, whether it's a deterministic pushdown automata or it's a case of non-deterministic pushdown automata, language acceptance can be done through two ways. First one, either we reach to the final state, or either we can just remove all the elements from the stack. So if I am considering second one also, this one is the acceptance to final state. If we want to remove all the elements from the stack, then this operation is written as, it means if you are on state K1, input symbols are no more, input symbol is epsilon, top of the stack is Z0. That means now I have to remove all the symbols from the stack. That means be on the state Q1 and remove all the symbols from the stack. That means remove Z0 from the stack. If we remove Z0 symbol is also from the stack, now our stack is empty and it will be shown through epsilon. So this one is the language acceptance by empty stack. That means I removed all the elements from the stack. So please remember that either we are taking the example of deterministic pushdown automata, or we are considering the non-deterministic pushdown automata. Language acceptance can be done through two ways, either through the final state, or it may be possible that acceptance by the empty stack. If you want to accept the language through final state, that your QF is your final state and top of the symbol top of the stack contains Z0. If you want to accept the language by empty stack, that be on that state and remove Z0 from the stack. If we are removing Z0 from the stack, that means now our stack is empty. If our stack is empty, it will be shown by epsilon. I hope now you are able to understand this concept. Just this one is non-deterministic pushdown automata. I am just going to repeat the main point, because in this example, in this language, we didn't know the center point. Center point is missing. We didn't know the center point. Fine. So we didn't know when we have to push the elements, when we have to pop the elements. As in deterministic pushdown automata, I am taking the example WCWR. There C is the center point. So we know that we have to push the elements before C. The elements that are before C, we have to push those elements into the stack, and the elements that are after C, corresponding to that, I have to remove those. On the occurrence of after C elements, I have to perform the pop operation. But in this case, center point is missing. So more than one cases can be considered here. That means for same input symbol, I have to perform the push operation as well as I have to perform the pop operation. Okay. Thank you.